Welcome everybody. Today we'll be solving Leetcode 2924, Find Champion 2. So they give us n teams, 0 through n minus 1, and each team is also a node in a DAG. DAG is a acronym for Directed Acyclic Graph. Okay. They also tell us that when we have a directed edge from A to B, we know A is stronger than B. Okay. They also tell us or ask us to return the team that will be the champion of the tournament if there is a unique champion, otherwise return -1. So let's go over this first example here. I've written it down here. Let me just make it a little, make it a little bit bigger. All right, fine. So we're given n equals 3 as input and these edges. So that means our possible candidates, so candidate champions would be 0, 1, or 2. They also provide us these edges here. So 0 to 1. So remember from up here, they tell us that that team A, a directed edge from A to B means that A is stronger than B. Okay, so that means 0 is stronger than 1. So that means there is no way that 1 can be a candidate. So now I'm going to remove 1. So now these are our candidates. Okay, moving on. They tell us that 1 is stronger than 2. So 1 is stronger than 2. That means I'm going to remove 2. So here we're left with 0. And this is unique. That means this would be the answer. So as it is here. Okay. Moving on. Let's go over this example here. Okay. So 4 nodes, and these are the edges. So that means the candidate champions would be 0, 1, 2, and 3. So let's look at this first edge here, from 0 to 2. That means 0 is stronger than 2. So that means 2 cannot be a candidate any longer. Moving on, 1 is stronger than 3. So I'm going to remove 3 because 1 is stronger than 3. So we're left with 0 and 1. 2. 1 is stronger than 2. I would remove 2, but it's not a candidate any longer, so we don't need to do anything. So we're left with two possible champions. But remember, they tell us that if they're looking for a unique champion, otherwise return -1. So if you notice, in this case, they return -1. So that's all there is to the problem, is that we just need to look through the entirety of the edges and remove the weaker node and then figure out the number of candidates left. So if we're left with one candidate, we can just return it. If we're left with anything more than 1, we can just return -1. And that's it. It's actually not that bad once we understand that. So let's set that up here. So let's make this as, we'll call this maybe candidates equals, and I'm gonna make a set out of range n. So this would essentially be what I've done here. So 4, range 4, and make a set of it. Now let's loop through the edges. For u, v in edges. So I can do candidates dot. Now there's two possible functions that are provided by candidates. Either we can use remove or discard. So I'll show you both and tell you or inform you which one is best. Now remove is used, or a good choice, or when we want to remove an element when we know the element is in the set. Discard says throw it away if it is or is not in the set. So remove will give us an error. So I'll just for now I'll just go ahead and I know it's not going to give us an error, but I'm gonna pretend and use it for now. And that's pretty much it. So then we've gone through all the edges, like I've done here, gone through all the edges, and we check if there's one element remaining. So let's do this, return return candidates dot pop if length of candidates else -1. So I'm going to test it locally, and this should be fine. Let's make it smaller, and then let's test it. Oh, remember I made a mistake. We're supposed to remove the weaker element, so this should be a V. This should have a V here. No problem. It's all part of development. Okay, what else happened here? Oh, did I spell something wrong? Okay. Okay. So remember, I use pop here because since there's one element in the set, when I pop the element, this will be that element. Okay, we're good. And if I'd used remove, this would have thrown an error because this says remove the element, and it checks if it's already there. So it says, hey, I can't remove, like in this example, it says like 2, when we were here 1, 2. When we tried to remove element 2, when we use discard, it doesn't matter because discard says I'm gonna try to remove it. If it's not there, no big deal. If it's there, I'll remove it. This is gonna give us an error. Again, I'm just showing it for educational purposes, and it'll error out. Yes, here, see, candidates removed. See, it's 2 is not there, so it throws an error. Other than that, let's just go back to what we had, and let's run it. And there we go. It's amazing. Not bad, 94. So I thought this was not that bad. If you have any questions, you'd like me to expound on it more or clarify anything, let me know. Otherwise, have a great day. If you find this educational or helpful, please like, subscribe, or comment. Take care.